This video is about solving for a variable in terms of other variables. These are called literal equations, and what you'll have to do is treat some of the variables like they're numbers and just move them around, just like when we're solving a regular equation. A literal equation is one where we're solving for one variable in terms of other variables, and you follow the same steps that you would when solving a regular equation, trying to isolate one variable. I have two examples here. The first one says degrees Celsius can be converted to degrees Fahrenheit using the following equation. F equals 9/5 C plus 32, and we want to solve for C, meaning get C by itself. So I'm going to go ahead and rewrite my equation here. F equals 9/5 times C plus 32. Now, if I'm trying to solve this, just like I would a regular equation, what I want to do first is move the 32 to the other side. So I'll subtract 32 from the right side, and I have to subtract 32 from the left side. And so this becomes F minus 32 equals 9/5 C. Now, the step that I would have to do next is I can multiply by the reciprocal, or the flipped fraction, that's attached to the variable I'm trying to solve for. So let me actually move that 9/5 C over just a tiny bit and leave some space in front of it. So I have 9/5 C here. And then if I'm trying to solve for C, I'm going to multiply that by 5/9. And I have to do the same thing to the other side of the equation. So I'll put parentheses around F minus 32 and multiply by 5/9. Now over here on the right-hand side, the 5/5 cancels and the 9/9 cancels. So I'm just left with a C here on the right-hand side of the equation. And on the left-hand side of the equation, I'm left with 5/9 parentheses F minus 32 equals degrees Celsius. So that would be my result. C equals 5/9 times the quantity F minus 32. So you can see I'm using the same ideas as when I solve for an equation with only one variable. I'm moving everything to the opposite side of the equal sign and just trying to get that variable I'm solving for completely by itself. Let's look at one more example. So here I have a linear equation. I have 4 equals 8x minus 18y. And I want to solve for y. So what I'll do, I'll start by subtracting 8x from both sides. So both sides of the equal sign. So I have 4 minus 8x equals negative 18y. And then I have to divide both sides by that negative 18 because I'm trying to get y by itself. So divide both sides by negative 18. And then on the right-hand side of the equal sign, I just have y. On the left-hand side of the equal sign, I'm actually going to split it into two fractions. So I'll do 4 over negative 18. minus 8x over negative 18. And now I want to simplify this. So I know that 4 over negative 18, I would have a 2 that goes into both the numerator and denominator. So this would actually simplify to negative 2/9. 4 divided by 2 is 2, and 18 divided by 2 is 9. Now here I have a minus, a negative, so that would actually become plus. Or you can think of it as a negative over a negative becomes a positive. Here I have 8 over 18. 2 is the common factor there, so divide 8 by 2, I get 4. Divide 18 by 2, I get 9. So I have negative 2/9 plus 4/9 x equals y. And I'm going to go ahead and write that as y equals 4 over 9 times x minus 2 over 9. That would be my result. Now you'll see more of these later when we start talking about linear equations and writing linear equations in slope-intercept form. But for now, we're just practicing solving for y when we have an equation set up in this form.